So in this video, we're going to talk about finding vertical asymptotes. Finding vertical asymptotes is a rather simple thing to do, but it is very important to understand and know how to find vertical asymptotes because it's going to be very crucial when we go about plotting our graphs. So I need you guys to recall one of the things we previously said. So if you guys remember, we say that whenever we plug in and our answer is this sort of a form, constant divided by 0, right? So then we can say that the value that x approaches, right, we can say that that is a vertical asymptote. Okay, so this is what I need you guys to remember for when we're finding vertical asymptotes. So we just saw that when we have a constant divided by 0, then we can say we have a vertical asymptote at the value which x is approaching. So when we're told to find vertical asymptotes, the idea is pretty simple. We just need to set the denominator equals to 0. So how this whole thing works is that, for example, I give you a function, right, y or f of x is equal to 4 divided by x minus 1. Now I am telling you to find the vertical asymptotes for this function, right, if they exist. It's not a must for every graph to have a vertical asymptote. So I'm just giving you this function and I'm telling you to identify the vertical asymptotes if they exist. So the general steps when we're told to find the vertical asymptotes is, first thing is that you need to simplify your function. After you simplify, then you set the denominator equals to 0. So let's try and use that for our given example. So we know that this function cannot be simplified, right? Because 4 divided by x minus 1 is already in its simplest forms. So in this case, step 1 is already done. So we just go to step 2, which is setting the denominator equals to 0. So I want x minus 1 to be equal to 0. So what value of x gives x minus 1 equal to 0? So if we solve this, we get x equals to 1. So that means that when x is equal to 1, the denominator is equal to 0. So when x is equal to 1, y or f of 1 is equal to 4 divided by 1 minus 1, which is 0. So this is a constant divided by 0 form. So if it's a constant divided by 0 form, so we can say that x equals to 1 is a vertical asymptote. It's a rather simple idea, and that is all that is about vertical asymptotes. So just to show that we are doing the correct thing, so this is our function over here, y equals to 4 divided by x minus 1. So if you look at the graph, we said that x equals to 1 is a vertical asymptote. So our vertical asymptote is this blue line. So let's say if this is actually a vertical asymptote or not. So if you zoom out, you'll see that it actually is indeed a vertical asymptote. If you zoom in, you'll see that the graph or the function comes pretty close to the vertical asymptote, but it never touches nor does it cross the vertical asymptote. So hence, in this case, we know that x minus 1 is a vertical asymptote for that graph. And as you can see, there are no any other vertical asymptotes. Okay, so let's do this second example. So we're given this function y equals to x squared plus 3x minus 10 divided by x squared minus 4. So we need to find out the vertical asymptotes if they exist. So we said the first step was to simplify the function. Okay, so over here, I know that the denominator, this part over here, is a difference of 2 squares. So I can write x squared minus 4 as x squared minus 2 squared, which is the same thing as x plus 2 times x minus 2. The top over here is a polynomial, so I can also factor it out. So x squared plus 3x minus 10. So my sum over here is this, which is 3, and my product is the coefficient of x squared multiplied by minus 10. So it's just 1 times minus 10, which is minus 10. So I need to find two numbers that add up to give me plus 3, but that multiply to give me minus 10. So it's pretty obvious. In this case, our two numbers are going to be 5 and minus 2, because 5 plus minus 2 is going to give you our sum, which is plus 3, and 5 times minus 2 is going to give you your product, which is minus 10. So now I can rewrite the polynomial using these two terms. I can write x squared. Again, the order in which I write the 5 or minus 2 first doesn't matter. In this case, I'll just go with minus 2. Minus 2x plus 5x minus 10. Now let's factor. So I can put x outside, x minus 2, write the same thing over here, and I'll have to put a 5 outside. So this is factored to x minus 2 times x plus 5. Now let's rewrite the original function and see if we can simplify it. So we can rewrite it as f of x equals to x minus 2 times x plus 5 divided by x plus 2 times x minus 2. So now in this case, we can cancel this and this. So we simplify the function to x plus 5 divided by x plus 2. We cannot simplify this any further, so now we can go ahead and set the denominator equals to 0. So I want the denominator to equal to 0, so x plus 2 has to equal to 0, so that means that x has to be equal to minus 2. So when x is minus 2, the denominator is going to be equal to 0. Now, so when x is equal to minus 2, our y value, or f of minus 2, is going to equal to minus 2 plus 5 divided by minus 2 plus 2, which is simply 3 divided by 0. And this is a constant divided by 0. So in this case, this x value will be a vertical asymptote. So therefore, we can say that x equals to minus 2 is a vertical asymptote. Okay, so let's look at this third example over here. We're given the function 4 divided by x squared minus 4, and we need to find the vertical asymptotes if they exist. So in this case, can we really simplify the function any further? Not really, right? Because although the denominator is a difference of two squares, you can factor it out, but that's not really going to simplify the function. So we can just go and set the denominator equals to 0. So we want x squared minus 4 to be equal to 0. So in this case, your x squared has to be equal to 4. So I can root both the sides, so this will get rid of the square root. So x is equal to root of 4. Now root of 4 is equal to plus or minus 2. Now this part over here is very important to remember because it's pretty obvious. See, when you have 2 square, right, you're going to get 4. But also when you have minus 2 square, you're going to get plus 4 because minus 2 times minus 2 is going to give you 4. That's why we have the plus or minus 2 over here. So that means that when x is equal to positive 2, x square minus 4 will equal to 0. But also when x equals to negative 2, x square minus 4 will be equal to 0. So in this case, you're going to have two vertical asymptotes, and one of the vertical asymptote is going to be at positive 2, and the other vertical asymptote is going to be at negative 2. So x minus 2 and x plus 2 are both vertical asymptotes. So we'll just have a quick look into the graph of the function so that things make sense. So as you can see, this is the graph of the function 4 divided by x squared minus 4. It's a weird looking graph, I'm not going to lie. But yes, this is the graph of the function. Now as you can see, our first vertical asymptote was at x equals to plus 2, which is this black line over here. So as you can see, the graph goes pretty close to it, but it'll never touch the vertical asymptote. Okay, so that's our first vertical asymptote. Now our second vertical asymptote is this red line over here, x equals to minus 2. So again, as you can see, the graph goes pretty close to the vertical asymptote, but it will never touch the vertical asymptote. So as we just saw, it's possible that a function can have a single vertical asymptote, or in this case, even more than one vertical asymptote. So let's look at this final example over here. We are given the function 1 divided by x squared plus 1. Can we simplify this further? Not really. So we need to try and set the denominator equal to 0. So we want x squared plus 1 to be equal to 0. So x squared is going to be equal to minus 1. And there is no real solution over here because we cannot take the square root of a negative number. So there does not exist a real number such that this denominator will equal to 0. So what does that mean? So that means that in this case, the denominator will never equal to 0. The numerator is just going to be a constant, which is 1 in this case, but the denominator will never equal to 0. Now, since we don't have the constant divided by 0 form in this case, that means that there is no vertical asymptote for this graph. So therefore, it's safe to conclude that there does not exist any vertical asymptotes for this function. Just to prove that we're doing the right thing, we'll have a quick look into the graph of this function as well. Here, so as you can see, this is our function 1 divided by x squared plus 1. And clearly, there is no vertical asymptote for this graph, right? There exists no vertical asymptote. So that is more or less the whole general idea of finding vertical asymptotes. It's nothing too complex. Just simplify the function first, and then find values of x such that the denominator equals to 0. If there exists such x value, then that x value is a vertical asymptote. If you cannot set the denominator equal to 0, just like in this final example, that means there is no vertical asymptote for that graph. And remember, it's not a must for the graph to have only a single vertical asymptote. We can have multiple vertical asymptotes or no vertical asymptotes as well. Thanks very much for watching.